Welcome back, everybody. Mr. Renneker here again. And in this next lesson, we are going to be using the Pythagorean theorem some more, and we're also going to be using that to learn about something called the distance formula. Your objectives for this lesson are to use something called the converse of the Pythagorean theorem, and then the distance formula, which we will experience shortly to help us solve some problems. Let's go ahead and jump into first some key ideas. The first key idea revolves around the converse of the Pythagorean theorem, which simply says if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is indeed a right triangle. So what we can use is this Pythagorean theorem as a form of a proof. In the last lesson, we were told we assumed that the triangle was a right triangle. What we're going to do is use the Pythagorean theorem to check if something's a right triangle. Let's see that first. So here we have two examples where we're going to tell whether each triangle is in fact a right triangle. So again, these should be yes or no triangles. Yes, it is a right triangle. No, it is not. So we're going to go ahead and start by using the Pythagorean theorem. And we're going to test using the values we have here and say, well, is this actually a true statement? Of course, identifying A and B, those must be the legs or the shorter of the two sides. And which one you make A and B, again, does not matter. I'm going to say that A is 9 centimeters plus B, which would have to be the 40 centimeter side. And again, we are asking, will that be equal to the hypotenuse, or C squared? Well, 9 squared, of course, then is 81. Plus 40 squared, which is 1,600. And does that, in fact, equal 41 squared, which is 1,681? This one becomes obvious very quickly because 81 plus 1,600 is 1,681. So are they equal to 1,681? And well, yes, of course. So when they say tell whether this is a right triangle, yes, it is a right triangle because we got a true statement. If we look at part B here, using the same idea, a squared plus b squared equals c squared, and speeding this up a little bit, we go ahead and substitute in our values for our legs and our hypotenuse. Before we go any further, some of you might be saying, oh, but this picture doesn't even look like a right triangle. I would encourage you guys to keep in mind that sometimes the pictures can be just a little deceiving. Be a little bit careful and make sure you actually work through the problem. We'll go ahead and simplify our squares. And you get the following, again asking, are these two statements equal to each other? On the left, though, you have 144 plus 324, which is 468. And we're asking, does that equal 576? Which is a big obvious. No, they are not equal, which means no, we do not have a right triangle. Again, looking at the picture here, you're like, well, that's pretty obvious, but that will not always be the case. So that's what you'll do. They won't always give you the picture, though, and that's what I'm going to let you try on your own here next. So just like our example, you can tell whether the triangle with the given side lengths is a right triangle by using the Pythagorean theorem. The converse of the Pythagorean theorem. Without a picture, some of us might be wondering, well, how am I supposed to determine which sides are which? And generally speaking, keep in mind that simply put, the hypotenuse is the biggest number. It's the longest side. And that's all you really have to be specific with, since the legs don't matter which one is A and which one is B. So looking at number 1, I see that 28 inches is the longest side. So there's your hypotenuse. And in number 2, I see that 1.25 millimeters is the longest. So that has to be our hypotenuse there. And that should help you guys get started. Go ahead and pause the video if you'd like to try these ones on your own. And I'll show you some solutions here in just a few moments. So number 1, unfortunately, did not work. It was not a right triangle. Number 2, though, those two sides of the segment would have been equal. So number 2, yes, was a right triangle. Now, that's how we're going to use the converse. And our next objective here was to learn about something called the distance formula. Let's take a look at that key idea. So the distance formula says that the distance, which we'll call d, between any 2 points, they call them x1, y1, and x2 and y2, is given by the following formula. If I were you, I would go ahead and pause the video here in a moment to make sure you can get that formula copied down, as you will be using it frequently in the second part of this lesson. Now, when we look at the picture here, you can see that line, that distance that they call d, right here. And if for just a moment you ignore the rest of the picture as best as we can, what we're saying here is that this distance formula, finding the distance between x1, y1, and x2, y2, finding the length of that line, we can accomplish by using this formula. So that's what we're trying to do. Now, going back to the picture, you see that they have drawn a right triangle. So what they have done here, in essence, is they went ahead and extended a line from x1, y1, completely and perfectly horizontal, in other words, following the same coordinates here to the right, until it was immediately underneath x2, y2, so that we have created a right triangle. The reason we do that is because once we can envision this imaginary right triangle here, we're able to apply ideas from Pythagorean's theorem. Well, what does Pythagorean's theorem say? Well, it says that if you take a and square it, plus b and square it, that has to equal side c, or the hypotenuse, if it's squared. Now notice here then that side c is the d, or the distance that we're trying to find here. So if we look briefly at Pythagorean's theorem, we say, well, we're just trying to solve for c. That's that missing side that the distance formula applies to. To solve for c here, well, all we'd have to do is take the square root of c, and that would be us solving for that variable, which means we take the square root of both sides. So c would be equal to simply the square root of a squared plus b squared. And without going to a much greater amount of depth here, notice that a, which we define in our picture, that's x2 minus x1, the same thing you see in this part of the formula. And b, which you see in our picture we labeled is over here, that's the same thing as y2 minus y1. So really all the distance formula is, ladies and gentlemen, is Pythagorean's theorem solved for the hypotenuse early. Let's see how that works in context of a problem. So what they'll do is ask us to find the distance between 2 points, and here they've given us the points 1, 5, and negative 4, negative 2. You want to start by having your formula written out, and start by substituting in your values. So to find the difference between the x values, it says x2 minus x1, our x values are negative 4 and 1, so take negative 4 minus 1, and we'll square that in a little bit, plus, and then the difference of the y values, and the y values are negative 2 and 5, and we'll square that. All right, negative 4 minus 1 is negative 5. We're going to square that. Negative 2 minus 5 is negative 7, and we're going to square that. And after we simplify that, we get to square root all of that. Let's see, negative 5 squared is 25, plus negative 7 squared is 49. 25 plus 49 is 74. And all we need to do then is find the square root of 74. Now, of course, 74 is not a perfect square, so finding the square root isn't an automatic thing. It's certainly not going to result in a whole number for us. The good news is, after our previous work, you do not need to estimate these by hand, ladies and gentlemen. So you actually have two answers. One version of the answer you could use is what you see here. You can actually leave it in radical form. So you could say the distance between these 2 points is the square root of 74. It is possible that you'll be asked to estimate or round to the nearest maybe tenth or so forth, but you are going to be allowed to use a calculator or other technology to help you do that. And if you are trying to follow along with this, the square root of 74 is about 8.6. So if you were going to use that method, or if you were asked to on big ideas, that's a decimal value that would get. Although, again, Leaving it in radical form is acceptable as well. I'm going to let you try just a couple on your own so you can try through this whole distance formula. And we'll check through these one at a time so that you can perhaps work through them all if necessary, or only some of these problems until you feel confident you're ready to work on the assignment on your own. So go ahead and pause the video if you want to try number 3, and the answer will show up in a few moments. So in radical form, number 3, the distance between the 2 points is the square root of 41, or about 6.4. Go ahead and pause the video then if you want to try number 4 on your own. And there, the distance between the 2 points would be the square root of 85, or about 9.2. And finally, for number 5, if you still need to work through that one on your own, go ahead and pause the video, and we'll take a look at the solution here shortly. And number 5 actually comes out to be a whole number. You should find that the distance between those 2 points is actually 5 units. I'm only going to say units because since these points would be located on a coordinate plane, they aren't going to have specific units always like miles or feet or anything else, unless this was a word problem or an application style problem, then they might give you units. As always, if you're still having difficulty or you have other questions, please reach out to me so I can try to help you out a little bit further. Otherwise, you should be all ready for your assignment. And you have some examples on all of our objectives. You've used the converse of the Pythagorean theorem to help you decide if a triangle is a right triangle. And then, of course, we've learned about this new distance formula that'll help us find the distance between any 2 points. Good luck on your assignment, guys. And as always, I will see you next time.